Have you ever stopped to think about the computer or phone you're using right now? At its very core, it speaks a simple language: ones and zeros, on, off, yes, no. This is binary, the foundation of all classical computing for the last century. It's built our modern world, from sending emails to landing rovers on Mars. But what if I told you we're on the brink of a new computing revolution, one that goes far beyond this simple binary world? A revolution that operates on the weird and wonderful rules of the quantum realm. Welcome to the dawn of quantum computing. So, what exactly is this mind-bending technology? Let's break it down. Your regular computer uses bits. Think of them like light switches. A bit can either be a 0, off, or a 1, on. It's a definite state. Quantum computers, however, use something called a qubit. Now imagine that light switch isn't just on or off, but it's spinning like a coin in the air. While it's spinning, it's both heads and tails at the same time. This is the principle of superposition. A qubit can be a 0, a 1, or both simultaneously. It's a mind-boggling concept, but it's this ability to exist in multiple states at once that gives quantum computers their incredible power. But wait, it gets even stranger. Qubits have another superpower called entanglement. Albert Einstein famously called it spooky action at a distance. Imagine you have two of those spinning coin qubits, and you entangle them. This means their fates are linked, no matter how far apart they are. If you measure one and find it's a 0, you instantly know the other one is a 1. It doesn't matter if it's in the next room or on the other side of the galaxy. This interconnectedness allows quantum computers to process information in a way that's fundamentally different, creating a complex web of calculations that are all happening at the same time. Now you might be thinking, okay, that's cool, but what's the point? My laptop works just fine. And for browsing the internet or watching videos, you're right. Classical computers are great for that. But there are certain problems that are so complex, they would take even the world's most powerful supercomputers billions of years to solve. These are the kinds of problems quantum computers are built for. Think about designing new life-saving drugs. To do that, we need to simulate how molecules behave, and molecules are quantum systems themselves. It's like trying to build a perfect model airplane using only giant, clumsy Lego blocks. It's just not the right tool. A quantum computer, however, can simulate these molecules with incredible precision because it speaks the same quantum language. This could revolutionize medicine. Instead of years of trial and error in a lab, we could design perfect drugs on a computer, targeting diseases like cancer or Alzheimer's with unparalleled accuracy. The same goes for materials science. Imagine creating new types of batteries that last for weeks, or superconductors that work at room temperature, leading to perfectly efficient energy grids. These aren't just small improvements. They're complete game changers for our society and our planet. Another huge area is complex optimization. Think of a delivery company trying to find the most efficient route for thousands of trucks in a massive city. The number of possible combinations is astronomical. A classical computer would have to check them one by one. A quantum computer, thanks to superposition, can explore all the possibilities at once and find the optimal solution in a fraction of the time. This has massive implications for logistics, financial modeling, and even helping us create more efficient artificial intelligence and machine learning algorithms. It's about solving problems that are currently unsolvable. Of course, we're not quite there yet. Building and controlling a quantum computer is incredibly difficult. Qubits are extremely fragile. The slightest disturbance, a tiny vibration or a change in temperature, can cause them to lose their quantum state, a process called decoherence. It's like trying to balance a needle on its tip. Scientists and engineers are working in super-cooled, ultra-stable environments to protect these delicate qubits. We're currently in the early days, similar to the 1950s, with classical computers that filled entire rooms. Today's quantum computers are massive, complex machines, but the progress is happening at an exponential rate. So, will a quantum computer replace your phone anytime soon? Probably not. They are specialized tools for specialized problems. Think of it this way. You have a car for driving on the road, but you need a rocket ship to go to the moon. Classical computers are our cars, perfect for everyday tasks. Quantum computers are our rocket ships, designed to take us to new frontiers of discovery that were previously unreachable. They won't replace our current computers, they will work alongside them, tackling the challenges that are too big for the binary world. The quantum revolution is more than just building faster computers. It's about a fundamental shift in how we approach problems, how we understand the universe, and what we believe is possible. We are learning to harness the very laws of physics that govern the smallest particles in existence to solve some of the biggest challenges facing humanity. From curing diseases to combating climate change by designing new carbon capture materials, the potential is almost limitless. We are moving beyond simple ones and zeros and stepping into a world of infinite possibility. The journey has just begun, and the future is going to be quantum. Thank you so much for joining me on this deep dive into the incredible world of quantum computing. It's a complex topic, but hopefully you now have a better sense of why it's so exciting. If you enjoyed this video and want to learn more about the technologies shaping our future, please hit that like button and subscribe to the channel. Let us know in the comments what future tech you're most excited about. Thanks for watching, and I'll see you in the next one.